Hi, hello everybody. In this video, I'm going to be explaining how to perform time series analysis using LSTM RNN. Let us understand with the use case of predicting Bitcoin's price. I'm going to be uploading a lot of AI videos every week, so if you haven't subscribed yet, please subscribe. Time series is a sequence of data points measured at a consistent time interval. Time series has various applications in the fields of data and time-driven decisions, which include sales forecasting, stock market analysis, process and quality control, workload projections, and much more. Now let us see what is recurrent neural net and how to forecast time series using that. RNN is called the recurrent neural network, which is widely applied over sequential data. If we want to predict the next sequence in a video, we want to know the previous sequence. Traditional neural network will not retain the previous sequence, but RNN will remember the previous sequence. Normal feed-forward neural network predicts output based on the current input, whereas recurrent neural network predicts output based on the current input, also the previous input. As you see in this figure, RNN has looped connections which allows the network to hold information across inputs. These connections are considered as memory. However, RNN has a shortcoming called vanishing gradient problem, which basically means RNN cannot retain information for a longer time in the memory. But how does this happen? When we backpropagate our recurrent neural net and calculate gradients with respect to the weights, the gradient tends to get smaller and smaller as we keep on moving backward in the network, which means that neurons in the earlier layers learn very slowly as compared to the neurons in the later layers in the network. LSTM is a variant of RNN which can be used to overcome vanishing gradient problems. Unlike other networks, LSTM has blocks instead neurons, and the block has gates like forget gate, which is responsible for deciding what information should be thrown away from the memory. Input gate, which is responsible for deciding which values from the input should be updated to the memory. Output gate, which is responsible for deciding what should be shown as output based on the input and the memory. Now let us write some code which predict Bitcoin's price using LSTM recurrent neural net. First, let us load all our necessary libraries. So once after we loaded our libraries, we load our data. So after that, we look at our top few rows of our data. We can see that we have a lot of columns like date, time, ID, market, RPT key, last. Similarly, we have a lot of columns. If you look at this particular column RPT underscore key, we can understand that Bitcoin's values are in terms of particular currencies like USD, Japanese, Korean. So what we can do is we can filter our data with only USD currencies. So once after we filter that, we will convert our datetime ID to a proper date type and filter the dates greater than June 28. So once after we filtering, we have a data with a proper sequence of time associated with a particular value. We will be requiring only this particular value called last. So we will subset that particular column alone and we will convert that column into a NumPy array with the float type. Neural networks are sensitive to input data, especially when we are applying activation functions like sigmoid or tanh. We have to rescale our data to a particular range. So we will rescale our data in the range of 0 and 1. We will rescale it using min-max scaler from scikit-learn. So once after we rescale our data, we will split our data into train and test. Now let us define a function called createDataset which actually takes two input. One is the dataset, the NumPy array that we want to convert into a dataset, and other is the lookback, the number of previous time steps to use as input variables to predict the next time period. So what do I mean by that? If I set lookback equal to 1, in train X, at the second position we have 0.498, whereas in train Y we have that in first position. Similarly in train X we have 0.18666, we have that here in second position. So with the look back of 1, x, y values are 1 time steps delay of x values. So after that we will reshape our input to samples, time steps and features in this format. Now let us build our model. First let us define our model to be a sequential model and let us add our LSTM network with 4 hidden layers, and now let us compile our model with mean squared error loss with Adam optimizer. So once after we fit our model, we'll make predictions with our train and test data. So after that we have to invert the predictions before calculating our errors so that our reports will be in the same units as in our original data. So we can see that We have like train score of 4.77 RMSE and with a test score of 5.57 RMSE. Now we will shift our train and test prediction for plotting. So we can see that our actual trend is in blue and our training trend is in orange and our test trend is in green.